Good morning, students. This is Arsna Sukla. I hope you all are fit and well and study well at home. So, yesterday we already talked about the composition of two functions. Now, today, and also some questions already discussed. Now, today we are going to discuss some theorem and then invertible function. So, first one is example number 18. So that if f from a to b and g from b to c are 1 1, then f composition g from a to c is also a 1 1 function. So let us consider, suppose uh, for f composition g to be 1 1, we need to show f composition g of x1 is equal to f composition g of x2 for each x1 x2 belongs to what? X1 x2 belongs to a. Okay, so let's see, for each x1 x2, so g of fx1 is equal to g of fx2 by definition. Being g is 1 1 from a to c, so this is fx1 is equal to fx2, and since f is 1 1, that's why x1 is equal to x2. So this is an important question, so please solve this. Now next, invertible function. See, on the top of this screen, if f from x to y is defined to be invertible, then there exists a function g from y to x such that f composition g is equal to ix and g composition f is equal to iy, then function g is called inverse of f and is denoted by f inverse. So this is the definition of invertible function. That's why you can say a function f from x to y, then inverse of this function is f inverse from y to x. It is only possible when f composition g or f composition f inverse is equal to ix and f inverse composition f is iy. So here some remark also. Thus, if f is invertible, then f must be 1 1 and onto. If f is 1 1 onto, then f must be invertible. So if we need to show a function is invertible, then we need to show f is 1 1 and onto. So this theorem is clearly states that f is 1 1 and onto, then f must be invertible, and f must be invertible if f is 1 1 and onto. So there are two methods to prove a function, given function is invertible and the inverse of the function is exists. So first one is what? If f and f inverse or f and g are two function and g is inverse of f, then if we want to show this function is invertible, then we need to show f inverse composition f is equal to ix and f composition f inverse is iy. So let's see, and second one is if f is invertible, then f is 1 1 and onto. So let us see example number 23. F from n to y be a function defined as fx is equal to 4x plus 3, where y is equal to y belongs to 1, y is equal to 4x plus 3 as for some x belongs to n, so that f is invertible and find its inverse. So given fx is 4x plus 3, we need to find inverse of this function, and it is invertible. So we need to show f is 1 1 and 2. So clearly from n to y, and y is given already, f is 1 1. Why? For each x1 x2 belongs to n. If for each x1 x2 belongs to n, fx1 is equal to fx2, then 4x1 plus 3 is equal to 4x2 plus 3. 3 cancel. So 4x1 is equal to 4x2, and then x1 is equal to x2. So this function is 1 1. And on 2 also, for each, let y is equal to 4x plus 3, then 4x is equal to y minus 3. So x is equal to y minus 3 by 4. So for each x, that means for each y belongs to y, there exists x belongs to x such that fx is equal to y. So fx, x, that is f of y minus 3 by 4, and if you solve it, then you get 4 into y minus 3 by 3 plus 3. 4 cancel, so y minus 3 plus 3, so y. So you see there is fx is equal to y, and this particular function x is equal to y minus 3 by 4, and inverse of the function is what? Nothing but inverse of the function is x is equal to y minus 3 by 4, and this is nothing but f inverse what? Y, you can say, that means y minus 3 by 4. So f inverse x is what? F inverse x is also x minus 3 by 4. So if you want, you can solve this by this particular method. And one method is also, if we suppose, the second one method, if you suppose it is given in the book, y is equal to this, then x is equal to this, y from g, y is equal to y minus 3, f composition g and g composition f. If you find, then see g of 4x plus 3, this is x, and g composition of f is also y. So this is invertible. So you can solve some more questions, and we are just discuss after the completing design. Maybe after this particular exercise also completed. So please try to do more and more question. In function, relation and function, we need to write. This particular chapter is based on only practice. Many questions you have to write many times, then only you are master of this particular chapter. Thank you.